first speaker is Joe Blaschka from the state of Washington. Joe is a registered professional engineer in 4 states and the principal and founder of ADCOMM Engineering. Prior to starting ADCOMM, he worked for Motorola and a small telephone equipment electronics manufacturer. Joe's been engineering and designing simulcast since the early 70s, and all told, ADCOMM has worked on over 500 communications projects, ranging from low-band paging to 900 megahertz trumpet. Joe has joined us every year at the Simulcast Forum, freely sharing his information, and we truly appreciate that for all he's done with us. We'll now hear from Joe. Please welcome him. That's a wireless recording. That's what people do.
All right, so all those wireless technologies you should know. All right, narrowband simulcast basics. First of all, for all of you that read the news about the change in the speed of rotation of the Earth, so the day is actually shorter now, that does not mean you have to go out and readjust your simulcast timing by 1.26 microseconds. Hopefully being a benevolent employer that I am, I gave that 1.26 microseconds to all my employees, so I can let them take that out of their workday. So they have a little shorter workday, whatever I can do to help in this tight economy. Anyway, for some of you, how many of you have been to the Simulcast Forum in the past? Okay, good. So that means I guess I can sit down. You already know everything there's going on Simulcast. One of the issues with simulcast in the past, where I've taught this sort of basic simulcast presentation, it actually takes a fair amount of time to do. So when Ed and I talked about it, we decided that we would just put the information in the past. These other times, maybe we'll go back and redo the real simulcast basics 101. What we wanted to do this time was cover some narrowband issues, since that seems to be the hot topic. It's interesting, narrowbanding has been around for a while. Up to 10 years, depending on, or longer, depending on which FCC ruling and rulemaking you deal with. But it seems like people are just now sort of waking up to it. So we're going to talk about that a little bit. So first of all, why simulcast? I think people pretty well have figured a lot of this out already. It's a spectrally efficient technology. Even in the rural areas these days, unless you're maybe out in the, I wouldn't say Wyoming, but that's not a good example because they're having trouble getting VHF channels. But let's say the Dakotas maybe, or some of these other areas, there might be places where you can still get VHF channels without too much trouble. But if you're near any sort of an urban or suburban area, you are probably going to have a lot of difficulty getting new VHF channels to provide expanded coverage or services for your customers. And narrowbanding doesn't really improve the congestion situation. And in fact, it may actually make it worse if people try to start fitting in narrowband channels into some of the existing channels. There was a pretty good presentation in the Narrowbanding 101 technical college classes that talked about that. So, particularly for VHF, it's a little better at UHF, but particularly for VHF, narrowbanding is not really going to help us the frequency situation. So simulcast is really a good way to help make better utilization of the channels you have. And with the modern technology that's out there today, it's a lot easier to do, and it's a lot easier to maintain. So I'll just flash these dates up there again. One thing is that I've started using the December 31st date and instead of the January 1st date, because it sounds closer. Just one day makes a difference, but when you say you have until 2012 instead of 2013, people pay more attention to it. So the conversion going from wideband to narrowband could be a big deal, it may not be a big deal. It's almost entirely related to how your system is, what your current coverage is, what the terrain is, what your current levels are, all of those things. Okay. So one of the big issues is that signal levels required to deliver the same audio quality level are higher. And Bertie Olson, I think, has a presentation later on that's going to talk about that. I'm not going to address that in much detail right now. But, you know, there's been a lot of talk on, like, the PWF forum, well, you know, if you actually measure the receive sensitivity of your narrowband receiver, it's actually better. You know, you're not changing your transmit power, so why is the range less? It should be better. Well, it all has to do with the fact that as you go narrowband, yeah, this is a big issue with simulcast as well, as you go to narrowband, your modulation index reduces to below 1. When you do that, your FM signal starts to become like an AM signal. And so all of the sort of benefits that you get from FM start to go away. And so that's why your range is reduced. It's related to the audio quality and the audio recovery. It's not related to signal strength. I mean, not your ability to detect the signal. The other thing you have to really watch for is that your radio specifications vary widely between brands and models. So if you go out and you look, you'll find that a radio that maybe had a really good 80 or 90 dB adjacent channel selectivity, and maybe was one of the best in the industry, when you go to narrowband and you look at the adjacent channel selectivity, you may find that that particular radio is no longer as good as some of the other radios that weren't as good in the wideband mode. So it's all over the place. So you really have to compare those because it's not the same. And you can add audio speech processing to really make a difference. This can make a difference on your wideband system too, but it can really make a difference on your narrowband system. You're already kind of down, you're working right at the edges of your ability to, hear and process audio. So adding speech processing can really help. When you do narrowband simulcast, it's just like wideband simulcast, but all the level settings are more critical and there's less tolerance for that. One of the complexities, particularly if you're using any type of older test equipment, is that most of the test equipment, the scales and the scales in particular, were not really optimized for narrowband FM, and it's really difficult to read, 2.5 kilohertz on some of the older pieces of test equipment. So, there's an impact there. Frequency stability shouldn't be a problem because if it was good enough for simulcast, it's certainly good enough for narrowband. And you use a GPS reference oscillator, and it really doesn't matter. Your frequency is just going to go away. Receiver capture effect is less with narrowband. So the exact amount is going to vary by the radio model, but our current sort of testing and estimate, we're using 15 dB as opposed to 10 dB for wideband. I'm going to cover this issue again. I cover it every year, but that's to remind people that if you pick up a textbook and talk about FM capture effect, it will tell you the number it's usually used is 6 dB. Well, that's the number that applies to typically the broadcast FMs, does not apply to two-way radio FM. Two-way radio FM capture ratio is much closer to 10 dB. And for wideband, when you go narrowband, the capture ratio gets even worse, which has a direct bearing on your simulcast engineering and on narrowband. So here's an example. Okay, so here's an example of a calculation we did. We've used this particular one before. This is a 4-site simulcast. This is one where our client actually said, we want you to use these 4 sites. They are already built. They didn't want to spend any more money on building sites. And so we put this in, and you can see, the signal levels here. Red means the signals are so good your antenna's on fire. You got here blue means you got ice on your antenna. So that's kind of how it goes. If you look at this, you'll see that in here, this gray area, though, is the area where you've got simulcast overlap distortion, where the audio is going to be distorted. In this particular project, this area right here is Interstate 5 going down